simplify the square root of 2i. Now, whenever we are talking about simplifying complex numbers, we want to express them in the form a plus ib. So we're going to write this into that form, in the form a plus ib. And so what we have is root 2i, and this should be equated to a plus ib, which we can also say as a plus bi. So what we'll do is we're going to square on both sides. We're going to square this side and square also this side. Please don't square these as individual terms. That would be a very big mistake to make. Now the root of 2i squared, we are just going to get 2i. And then if we square this one, a plus ib multiplied by a plus ib, that will give us a times a, that will be a squared. A times negative a times ib, that will be ab and then I. And then this times that will also be abi. And then this times that, it will be b squared I squared. And so we can now say this is a squared. We can add these as like terms. That will be 2abi. And then where there is I squared, we can put negative 1. So that will give us negative b squared. And so this is the same as, now we can also write it as a squared minus b squared plus 2abi. So 2i is the same as a squared minus b squared, then plus 2abi. Now what we have here is, this doesn't have an I, so this is the real part. And then this number here has got an I, this is the imaginary part. And as we can see, we don't have anything without an I there. That means the real part is 0. So that means a squared minus b squared should be equal to 0. And then the number in front of I, the 2ab, should be equal to the number in front of I that side, which is a 2. Now at this point I can divide through by a 2, so that will give me ab being equal to 1. And if I make any of these the subject of the formula, either a or b, let me make a. That will give me a being equal to 1 over b. Okay, in that manner. And so now in this equation, where I'm seeing an a, I'm going to put with 1 over b. So that will give me in a squared minus b squared being equal to 0. Where there is an a, I'm going to put 1 over b, and then everything will be now squared, and then minus b squared, that is going to be equal to 0. And this will give 1 over b squared minus b squared, and that is going to be equal to 0. Well, at this point, I can multiply everything by b squared so that I do away with the fraction which I'm seeing. 1 over b squared times b squared will be 1. B squared times b squared will be b to the power 4. And then 0 times b squared, that will be 0. Let me take b squared the other side. That will give me 1 is equal to b to the power 4, which is the same as b to the power 4 is equal to 1. Well, at this point, let me write this as b squared and then a squared, and that is equal to 1. And I'll say let x represent b squared. So where there is b squared, I'm going to put x. So that will be x squared is equal to 1. Well, to find the value of x, I'm going to square root on both sides. So that will give me x being equal to 1, or x is equal to negative 1. Well, I don't want the value of x, I want the value of b. So I can now go back to this one. We are saying b squared is equal to x. So I'm going to say that b squared is equal to 1, or b squared is equal to negative 1. We don't want b squared, we only want b. So we're going to square root. Again, like that. So that means b is going to be equal to positive 1, or b is equal to negative 1. Now for this other portion, if we want to remain with b, that is going to give us b squared being equal to negative what? 1. Now we're going to take the square root like that. So that will give us b being equal to the square root of negative 1. And you know that the square root of negative 1 is what? Is an I. So that means b is going to be equal to I. Okay. So at the same time, it is also positive or negative. So it can either be positive I or negative I. Okay. So after finding this, So I'm going to keep this portion which is here. So we found that this b can either be 1 or the b can be -1, or this b at the same time can be -I, or the b can be equal to +I. Now we know that a is 1 over b. That means a is going to be equal to 1 over, if b is, so I'm going to take each of those values now in this case. When b is equal to 1, we know that a is equal to 1 over b, to be 1 over 1, which is going to give us a 1. Okay, that is the first one. And then when b is equal to -1, that means a is going to be 1 over what? -1. And that is going to give us -1. Okay. And then when b is equal to +I, that means our a is going to be 1 over a, which we can also, to take the I on top, we can multiply down by I, even on top by I. So I times I will be -1. And so on top, that is going to give us -I. And then when b is equal to -I, that means our a is going to be 1 over -I. So again, multiply by I, multiply by I. So -I times -I will give us -I squared. Now where there is I, we can replace -1, so that will give us a 1 just, and so this will give us just I. And then now we can go on and conclude for this one. So therefore we are saying the root of 2I is equal to a plus IB. And so where there is a, for the first instance, where there is a, if we put 1, then where there is b, we're also going to put 1 for this one. So that would be the solution. Apart from this, root 2I can also be, for the second one, where there is a, if we put -1. That means where there is b, we're going to also put -1. So that would be -I. Okay, for this other one, that will give us root 2I is equal to, where there is a, we have seen -I. And then plus I. All we are doing is substituting in this one. Now where there is b, notice that we found that is I. And you know that I times I is a what? Is a -1. So this will still give us -1 minus I, which is the same as this one. And then going to the other one, root of 2I is going to be equal to, where there is a, we are going to substitute our a is what? I. And then plus, we are going to write I. Now where there is b, we are going to put -I. I times -I will give us -I squared. If we replace where there is I squared with -1, that will give us +1. So it will give us +1 plus I. That means this value again is the same as that one. And so we only have two values. We only have this and this. That means that root 2I is equal to 1 plus I, or -1 minus I.